Good morning, guys. We're going to start analog communication revision. It's just going to be in a 30 minutes. This we're going to be quick, and I'll be explaining every topic. What is it, and how do you need to approach in the exam? That's it. First of all, you know what's analog communication. The communication which happens in analog medium is called analog communication. Parts of communication system parts of communication system means it's also like the question will come in format of would draw the block diagram of communication system. There's a sender. Sender is the part where it sends the message, and channel is a medium, and receiver is the one which takes the message. So this is a pass, and this is a normal one, sender and transmitter, sender, channel, and receiver. This is a normal one. And types of signals. As you can see the block diagram, like a flowchart diagram of types of signals. There are basically two types of signals, analog and digital, in which periodic and aperiodic. What is the meaning of periodic? Means it's symmetric. Aperiodic means it's non-symmetric. Analog signal. Okay, basically I would say analog signal is a signal which has a continuous variation of time is called analog signal. Time varying quantity is an analog signal, and digital signal which does not have a continuous value of time. At a random sequence we get a random units of time. This is a digital signal. So periodic signal is like this one view, so everything is in period form with the, let's take an x of t as a variable and it changes for every instance, so we get a sinusoidal signal just as this is a sinusoidal signal. So this is a periodic analog signal. Analog a periodic means which does not have a uniform level, or it's an x of t is different. So that's it, and this is the thing of um, and what's modulation? So modulation means changing of the carrier signal, superimposing the carrier signal into the message signal is called analog signal. So modulation. So what is the basic need of modulation? So need of modulation is to send low capacity messages to far places. That's one thing, and advantages of modulation. And basically I would be saying what is modulation is like, if you want to send a message signal which has very low capacity or low power, so you need to send it for a half, like larger distance, then you need to do modulation. The modulation process involves that you are superimposing the carrier signal with the help of message signal. Superimposing message signal with the help of carrier signal. Then you're sending that total modulated signal to the receiver. That process is called as a modulation. So what are the advantages of modulation? As we can see, reduction of antenna size, so no signal mixing and increasing communication range, multiplexing of signals and these all things. And so types of modulation, this one is important. So types of modulation, we got two things here: continuous wave and pulse modulation. And as continuous, basically we totally for continuous wave modulation we say it's an analog modulation. When we go to this one, pulse modulation, it's a digital modulation. You see. So in continuous we have a AM, that's means amplitude modulation, and again angle modulation is divided into two types, which is frequency modulation and phase modulation. And in this analog modulation and digital modulation, the changing the parameters different in that. So pulse amplitude, pulse width, pulse position, pulse code modulation, delta modulation. We'll go depth into the next things. Well, basically, I'll not explain much about here, but I'll explain more later. And this is a baseband signal. You have to remember what's a baseband signal. So baseband signal is a message signal, and a carrier signal which is high frequency signal, and a baseband signal is a low frequency signal. And this is the so after superimposing the baseband signal and carrier signal, you'll get an image like you'll get a figure like this. So like this is an under modulated AM signal. So it's AM modulated signal, and this one is a maximum amplitude, and this you can see it from here. And there are the expressions of it. Let's just say M of t is an equation for the message signal, which is AM cos 2 pi FMT, and C of P is a equation for the carrier signal AC cos 2 pi FCT. And the superimposition means when multiplying those two signals, then we'll get AC plus AM cos 2 pi FMT into cos of 2 pi FCT as the equation. Modulation index is the like parameter which calculates the depth of the modulated level. That means how much did we modulate. It calculates. So that's we use a parameter like modulation index. That's it, and we like calculate by A by AC a simple equation like a simple formula. We take mu is like the formula we have like A max minus A min by A max plus A min, which comes from the those formulas only. And there are three types of modulation index, which is under modulated wave, vertically modulated, and over modulated wave. That means when mu is less than one, then it is under modulated, equals to 1 is critically, over means it is greater than 1. That's called it. And what is the bandwidth of an AMU? Bandwidth is defined as the uh, difference between the highest and the low frequencies. We say mathematically, but bandwidth is the range of the frequency which it allows, basically that format. So f max minus f min, basically the bandwidth of AM signal is 2 FM, and we can see it is from the diagram also. So fc minus fc plus fm minus of fc minus fm, then minus gets like minus fm minus fc gets cancelled and 2 fm will get. And here comes the power calculation of AM wave. And AM wave is like when you got the equation of AC plus AC not mu FM plus FM and minus FM, the two side bands, and you will be having like PT is equals to PC plus PUSB plus PLSB. USB and LSB are the upper side band and the lower side bands. So PC is a power carrier. I mean carrier power plus upper side band, carrier upper side band plus lower side band. And we say it as PRMS. Like this is the standard power cost formula as we know. And here comes the PC AC root 2 whole square by R. That is AC square by 2R. We get the PC PUSB as AC square mu square by 8R, which is also PLSB. I mean PUSB is equals to PLSB, and we get the total formula as PT is equals to PC into 1 plus mu square by T. We get the PC is equals to AC square by 2R, and these all are important for mathematical problems. And here we'll do one thing. M of T signal is 10 cos 2 by FCD. That means AM is 10 and FM is 10 to the power of 3. We got it here. And C of T is 50 cos. So AC is 50 and so what is FC is 10 to the power of 5. Find modulation index. What's the formula for modulation index? AM by AC. And the carrier power PC is equal to AC square by 4R. Which we are 4. And then what is the peak power required to transmit, and that's one. And it's variable by C, so basically by 2R. And peak power transmitted is like total power is PC into 1 plus mu square by T. That's one thing. And here the equation of amplitude equation, we find the carrier power and sideband or PLD, PLSB and bandwidth is same. Bandwidth anyhow is 2FM, PUSB and PLSB have a formulas. You can calculate from that. And so what are the modulators that we are having right now is we are having two modulators, square law modulator and switching modulator. So what is a modulator is like which generates an AM signal, we say it is a modulator. So square law modulator which takes an M of T and which gives the square law device. Square law device is a basic generator device which generates the AM signal. This is a big one, and you need to definitely remember this sort of equation one. And V2 is equals to K1 V1 of T and V1 square of T. Vn is M of T plus, you need to substitute in it and you'll get the equation. You'll get the Km of T is in different form. And in the switching modulator, we in this square law modulator, switching modulator is different. We have the switching diode. which is a different one, and we'll use the switching cases like V2 of t is V1 of t, where switch is greater than 0, 0 is switching less than 0. Then we'll get the cases over here and we'll get the analog signal in the mask. That's a simple one. You need to just understand the basic equation and figure out the block diagram. I mostly prefer that you need to get thoroughly with the block diagrams and you need to understand the equations, and you'll definitely get to the last final derivation equation. And next we go into square law demodulator, which is absolutely easy. Square law demodulator is like giving the AM wave and getting the M of t signal, and which means every demodulator is has a low pass filter, and that's important one. And not more that's not rocket ship is very easy. And we go into the DSBC modulation. What is DSBC modulation? Is double sideband suppressed carrier signal, and so we are having two sidebands in that position. So we are using the suppression of carrier signal. Then we are using so that we can reduce a little bit of efficiency. For that, we can increase a little bit of efficiency for that. And here comes the M of t into C of t signal. That's a basic equation for DSBC. And for the same, AM and DSBC are same. Power calculation is also the same. This slide different than, and you can just see there's only one side that we use in this. That's it. Balance modulator, and which you can see the figure. A modulators are two types. Till we say we are giving a two signals from S1 of t and S2 of t, which are 90 degrees space between both of them, and we like integrate with those two with the rest of the signal. We get an what do you say? This is the ring modulator is the basic one. We need to if we get a question about ring modulator, you need to have a clear-cut idea about when does the diode get on and when in which case diode get on and in which case diode get off, and you need to get that format and you just draw the diagrams and write the equations for that, and that's not very detector is very easy. Product modulator, the output of the product modulator which comes and you need to pass it through low pass filter, and then you'll get the product detector, and these are the very simple ones on co-star loop. This is very important. Co-star loop is very important and very perfectly. So you need to just understand the figure product modulator going on two sides. VCO is voltage control oscillator, which constantly controls the voltage level and gives the voltage level to the 90 degree phase shifter, and it gives the open to the modulators, and in which there is a 90 degree phase shifter, so that if the upper one goes to cos 2 pi fcd plus 1 and the lower one goes to sin 2 pi fcd pi, then the phase discriminator comes and you get a DSBC signal of class. So so SSB is simulation is single suppressed carrier signal. Single suppressed carrier signal in which we are suppressing only total one band and we are using it, and this is a very high one so that the efficiency is more in there. Efficiency is more, so we are using this not the LC of t, and the S of t basically says that A and AC by 2 cos of 2 for FC minus FM of t or FC plus FM of t. If you use either in upper sideband case or in lower sideband case, that depends upon what sideband are we using. In this, we are suppressing the carrier signal as well as one of the sideband signal. That's why the usage of the power is getting reduced and the efficiency automatically gets increased. So power calculations you can see from here, and there's a slide between only one. Power calculation is this simple, like you can get only power calculations using one sideband. That's the power calculation. And the advantage is band spectrum is more than is less occupied less transmission or signal. This is a very simple policy and high power transmitted disadvantages applications. You can just go through this. I'll leave the this page link in the description, and analog SLPSC modulators, and you can go through this product modulator, local oscillator, and band pass signal, and phase. This is not much phase discrimination method and phase discrimination or frequency discrimination. That's just simple and as usual, and we need to just focus on what diagrams are we drawing. That's it. Coherent detector or non-coherent detector is a basic one. Coherent detector, which has local oscillator and power modulator, and which you need to want more points. And here comes the, I think, VLBS is vestigial sideline, which mostly used about the for TV applications. The question comes in what method you using VSBSN, and for television we have to understand VSBSC. Why we are using VSBSC? This part of LSB will be called as FV. So that vestigial sideline, which is used for the some part of video frequency, and we say applications in VSBSC television signal generation is the same signal shaping filter. It's not much more important, but it's simple. But you need to go through that. And angle modulation is like there are two types of like one is the frequency modulation, another one is the phase modulation. Frequency modulation is like modulating the frequency. So frequency modulation is given to the carrier signal. There are two when the in FM modulated signal there are two frequencies. One frequency which is having very less time period, another frequency which is having more time period. According to my cursor, you can observe what is the variation in different modulated signal, and you can see all the mathematical representation. Delta by FM is the bandwidth modulation index, and there are two types of FMs. One first one is narrowband FM and wideband FM. We can say for a narrowband FM, the modulation index is small or less than 1. The narrowband index in this wideband FM is large. So wideband FM has a bandwidth of infinity, and here we have a delta FM by approximately around 2 FM only, around AM. So that's this point. And phase modulation, it depends upon the phase. For every 0 or 180 degrees, there is an instantaneous change of the signal. There you can observe it, and you get a signal. You can get a lot phase is which plus 5 is added for the signal. And here are the numerical problems. So here asking to calculate the frequency deviation for delta F is equals to kf into m. Kf is the modulation index, am is the amplitude of the index. Modulation index is data is going to delta f by fm. And what is the next one? I think he's asking bandwidth. Bandwidth for the narrowband, or he's asking for the sensor signal frequency generates shortwave. He did not mention this narrowband, so we can use if it's in narrowband, it's 2 FM only. So FM is given, so he gives calculate the deviation, and it is simple for that. We can have the formulas, and we can do it in the simple method. FM modulator, so first is generation of narrowband FM modulator, and in which we are using this integrator, which integrates the device of MNOT signal. It's like simple like a that integrator acts like cutting into different parts of the MFT signal and give it into product modulator, and product modulator like multiplies the signal and it's equal to by f, and the signal comes to it. And generation of WBMS wideband frequencies two method. One is direct method and indirect method. First direct method is VCO, that is voltage control oscillator, is directly given, and indirect method is they converting into narrowband without generating the narrowband FM and getting it into frequency multiplier, and then we can generate the wideband FM. And so frequency discrimination method and FM demodulators, frequency discrimination method and phase discrimination method, then both are same. Discriminator and envelope detector are used in this low pass filter, and VCO are used. That's as simple as very simple as that. Next one is multiplexing. So multiplexing is very simple. So multiplexing is a signal where you need to combine a number of n signals into one signal, and demultiplexing is dividing or extracting one signal to n signal. Is called multiplexing. As you can see in the digital multiplexer, digital electronics multiplexer, digital um, BMUX is one to many and many to one. In this multiplexer, analog and digital, FDM and WDM and TDM. The analog in this mostly we can observe that FDM and TDM. So basic, I'm going to explain how does it work and TDM and these all things. So generally, the difference is that the parts of work they have been done or how does it operate. So MDM it operates on the separation of the frequency levels. For every particular frequency there is another operation. For time division multiplexing. So there is an time slots between every guard band. There is a particular time slot to do such a work. So that we say it as a time division multiplexing. And Dmux is the same thing where we go to it, and noise is an unwanted signal which we everyone do. It keeps the headaches for all of us, and which is very like what we say we need to remove it. There are types of noises: external noise, internal noise, industrial noise, and white noise, thermal noise, etc., etc. Johnson noise. There are many noises, short noise, and we need to just extract, like we remove as soon as possible. And to say 100%, they are noises at every level of any communication. So there is no such a communication which is 0% of noise. So so we can make use that the noise should be as less as possible. That's it. Effects of noises, you know what the sensitive device get like, and there are many more effects. What is SNR is like output. SNR is a signal to noise ratio. What is SNR is input SNR. Figure of merit is output SNR by input SNR. So SNR, we need to calculate the SNR is a factor of calculating noise. So figure of merit is a factor. Okay, that's the simple part. So how do you calculate figure of merit is SNR output by SNR input. That's it, very simple. SNR calculations in AM systems is very so you need to understand every when you need to calculate for every system, then it's very easy. So I'll just explain of the one system you'll get easy. You'll get AAC. You can calculate S1 as the input and S1 as output. So you can divide it from that and you'll get S1 output. So SI by NI and S naught by N naught. So you'll get SI by N naught as equation 1, S naught by N naught is an equation 2, and you can divide equation 2 by equation 1, then you get total figure of merit. So this is the basic equations. So in same method follows for every modulation system for SSB or SSB. So you need to like have for calculating the SNR, you need to prerequisite about their formulas. N1 like formulas are S1 is the input signal, S0 is the output signal of any signal. Like if you say AM system, that S1 is the AC plus AM of 1 plus KA into 2 pi FCD. That one will be the S1 signal, S0 signal, and S1 is the input signal what you are be given. N1, N0 is an output signal, eta FM, and Ni is an input noise signal, and this is the constant one. And you can observe in it, and these are very simple. It changes for every system because of their output and input S1 and S0. So AM transmitter, we know what's a transmitter which transmits the signal. So the amplifier means which amplifies before. That's a game for EM modulator. You all know EM RF oscillator. It generates a carrier signal. Power amplifier which amplifies the signal. Antenna is an transducer which converts the electromagnetic electrical signal into electromagnetic signal. FM transmitter in which we have HPF is high pass filter and RF oscillator. Same, we know what is high pass filter. FM modulator, frequency multiplier, and power amplifier. You need to be thorough with the block diagrams. That's it. Nothing more or nothing less than that. The requirements on this is the sensitivity is about cost effective and it should be able to receive very low signal, and there are few characteristics you need to understand, like why do we need a good receiver, because the sensitivity, selectivity, bandwidth, and these all things should be given so that if the frequency is good. And the one was aim receiver. There's only one receiver, this is super dendroid receiver, that's one is important. That's quite important. And here comes to sampling. Sampling is a process of converting a continuous signal into discrete signal. This is in sample signal. So sampling is pure TS, 1 by TS as a sample frequency, TS is a sampling theorem states that the sampling theorem states the signal must be exactly reproduced the twice of its frequency or equal to or twice of its frequency. That means when a signal should be reproduced, then the FS signal or the sample signal should be equal or twice. It should be twice. That's a very simple one. And if it's omega, then it should be equals to omega or 2 of u. Simple as that. Pulse amplitude modulation is amplitude modulation which with the instantaneous changes of the pulse, we modulate pulse signal. That's the pulse amplitude modulation. So natural pulse is like cutting the edge of it flat off. This is the types of sampling also we can say. This we have PWM, PM, and these are the one more important, very much important. What are the difference between PAM, PM, and CPM? And these are very important. So you need to look through this differences for that, and I think this will be transducer. I'll just explain what is a transducer and then we can finish on this. So transducer is like an alternator or medium which converts the one form of energy into another form of energy. I'll just give a simple example. So if there is a loudspeaker, so when we want to hear an audio signal that's in the form of a speech. So the loudspeaker works as when we give the input as an electric signal, it converts the electric signal into speech signal like music or anything else. So that's is called as an transducer. So converting of one form of energy into another form into transducer or transducers. These are much you need not to understand this. Yeah, that's it. And I'll just briefly explain about this. I would say what are the things you needed for going through again when you're going that. First one is you need to understand what is analog communication, and then you need to know basic parts of the analog communication system, building block diagram of communication system, AM and DSBC, SSBSC, and these are block diagrams and their demodulators figures, and then you go to FM and PM, that is phase modulation and frequency modulation. Then you go to their generators and demodulators. Then you go to the what do you say? You go to the VSBSC and take the differences between AM, DSBSC, SSBSC, PM, FM, and DSBSC. So that's one more important so that you get grasp all the knowledge at once time. So that's the one thing, and write down the formulas at every level so that you can understand that. And you need to go through the modulators and SNR calculations, transmitters, receivers, and sampling methods, and these all things. Transition. I think I have not covered the full of the syllabus, but for the last time preparation, you can solve these all things. And most importantly, you need to go through all the formulas. Those are very important. Formulas are paka important. Thank you.